For more than a century, the reason why the dinosaurs went extinct 66 million years ago has been hotly debated and a topic of much interest. Since 1980, the prevailing idea is that the extinction was caused by the impact of a 10-kilometer asteroid flying out of space and impacting the Earth with a huge effect. Indeed, the impact did happen, and the dinosaurs other than birds did go extinct. But is that the whole story, or is it too simplistic? First of all, some points of clarification. The greatest mass extinction in Earth history happened 250 million years ago at the end of the Permian, and the dinosaur extinction is only the second or third worst extinction in Earth history. But the general public only cares about dinosaurs, and when you combine that with the idea of an impact, it's sexy enough to reach the public consciousness and even make the cover of Time magazine. Another clarification. Originally, it was called the KT extinction, for K for Cretaceous and T for Tertiary, and that terminology has been in use since the 1980s. But in recent years, we replaced Tertiary with Paleogene, PG, so it is now called the KPG, or Cretaceous-Paleogene extinction. Another key point is that almost all the older ideas about the extinction were focused on the dinosaurs and what would cause them to go extinct. But this is an extreme example of what is called dinocentrism. Every sort of idea has been proposed, including got too hot or too cold, that dinosaurs couldn't eat the angiosperm flowering plants, although angiosperms appeared in the early Cretaceous and actually spurred dinosaur evolution, that mammals ate their eggs, although mammals and dinosaurs both evolved about the same time at around 210 million years ago, that they died from colds or viruses, or the race became senile. In fact, many ideas have been proposed. These include all sorts of scientifically untestable notions, not the least of which is aliens snatching them up and taking them off in spaceships. The key thing to remember is that it's a global mass extinction that started with the plankton in the ocean and the land plants and worked its way all the way up to the top of the food chain. So any explanation that focuses on the dinosaurs completely misses the point. Instead, you need an explanation that focuses on what happens to marine life, and the dinosaurs are an epiphenomenon, an after effect. The topic remained one of idle speculation until a young scientist named Walter Alvarez, whom I knew as a postdoc when I was at Columbia Lamont Geologic Observatory, noticed something interesting about a section of Italian rocks near Gubbio, Italy. He noticed that the Cretaceous limestones, on the right here, were covered by a layer of black clay and then a layer of tertiary or Paleogene limestones that had totally different planktonic microfossils. This clay layer marked the KPG boundary, and he wanted to determine how long it took for it to be deposited. His father, Berkeley physicist Louis Alvarez, suggested they look for the evidence from cosmic dust that had settled out of the atmosphere. If it was a lot of iridium from cosmic dust, then it would be a very, very slow rain of extraterrestrial materials. If it was just a little bit of dust marked by a tiny bit of iridium, then it had been deposited rather quickly. Instead, they found a huge amount of iridium, indicating something altogether different. Over the next 2 years, the two Alvarezes, plus Helen Michael and Frank Asaro, who did the chemical analysis, racked their brains for an explanation until in 1980 they published a paper where they argued that a 10-kilometer or 6-mile diameter asteroid had flown out of space and had hit the Earth with a tremendous impact that caused tsunamis and caused gigantic effects not only on the land and the oceans, but also formed a nuclear winter cloud of dust in the stratosphere that darkened the Earth for weeks to months after the impact. For a decade after the original 1980 paper, more and more iridium anomalies, shown here by red dots, are being found, but no one could find the actual impact crater itself. Finally, in 1990, they identified a site on the tip of the northern Yucatan Peninsula that could explain all the impact debris around the Gulf of Mexico and the Caribbean. When geophysical studies were done, they found that there's a giant buried crater underneath the Yucatan jungle in a place called Chicxulub, the Mayan name for the nearest town above the buried crater. That is all the public usually hears, but is it the complete story? It turns out there's another huge event, the second largest volcanic eruption in Earth history, the so-called Deccan volcanoes in eastern India and parts of Pakistan. These eruptions covered over 200,000 square miles with a volume of 123,000 cubic miles of lava that cover many, many miles of India and Pakistan. This incredible pile of stacked lava flows would have produced enormous numbers of gases in the atmosphere and had a dramatic effect on climate. And the eruptions began just before the end of the Cretaceous. Not only that, but the Cretaceous marks one of the biggest drops in sea level in all of Earth history, exposing huge areas of shallow seaway and killing off all the shallow marine life that would live there. So the popular media and a few scientists oversimplify what is actually a complex story with three simultaneous events going on that could cause mass extinction. Which ones are the most important? Well, let's look at the fossil record and see what we can determine. Let's start with the bottom of the marine food chain, the microplankton. Some groups, like the algae known as coccolithophores and the amoebas known as forams, show extinction. The three other groups of plankton show no effect whatsoever. There is no evidence that marine reptiles, such as plesiosaurs and mosasaurs, ever saw the end of the Cretaceous but died out long before. Two other important marine groups in the Cretaceous, the cone-shaped rudistid oysters and the giant dinnerplate clams known as inoceramids, both vanished long before the rock from space appeared. The coiled relatives of the nautilus, squids, and octopus, known as the ammonites, were in gradual decline through the late Cretaceous, and now there is good evidence that they actually survived well into the early Cenozoic in several places on Earth. So to summarize, only a few groups of plankton died out precisely at the impact, and many groups had gone long before it or showed no effect whatsoever, like clams, snails, nautiloids, and many others. And ammonites survived well into the Paleocene. What about land life? Once again, there's a big change at the base of the food pyramid with the land plants, especially the pollen known as Aquila pollinides flora, which vanishes at the impact. As far as land animals go, indeed, the non-bird dinosaurs vanished at the end of the Cretaceous, but there's a lot of argument as to whether they did so slowly or abruptly. But that's the only land animals that died out. The crocodilians, the campsosaurs, the turtles, and many types of amphibians showed almost no extinction across the KPG boundary, even though these things should have also been affected like the dinosaurs were. So the story is much more complicated than the media would have you believe, and the impact could not have been as severe or as protracted as some would have you think. In some extreme versions of the impact hypothesis, it was argued that the Earth was bathed in acid rain due to the gypsum on the impact site. But this is bunk. If this had actually happened, there would not be a frog or salamander on the planet today, because they're extremely sensitive to fresh waters being contaminated by acid, and in fact, many of them are dying out now due to human-caused acid rain. So in contrast to what you have the media saying, in fact, the answer is it's complicated. Yes, a few groups died out right at the impact, but many were gone long before it, and some died out in coincidence with the eruption of the Deccan volcanoes. Indeed, the answer to most scientific questions is, it's complicated. It appears the Deccan eruptions were already making the world quite stressed out and causing extinction, and the impact was at best a coup de grace, finishing off whatever survived. But the media, and many scientists, prefer simple, cut-and-dried answers that ignore these problems. Paleontologists, on the other hand, with their backgrounds in biology, know that biological systems are not simple. The last time a poll was conducted of vertebrate paleontologists, a majority of them did not agree that the impact was the most important factor in the mass extinction. I have watched this debate go on for 45 years now, swinging back and forth with no consensus. Careers, grant money, and reputations are at stake, so no one's ever going to back down on this argument. And no matter what you hear in the popular media, the answer is still, it's complicated. The media love to have simplistic, cut-and-dried, soundbite answers that are easy to remember, but scientists do not have that option. Instead, we must recognize, as H.L. Mencken said, for every problem, there's a solution that's simple, neat, and wrong. Whatever the causes of the Cretaceous extinction, without it, dinosaurs would still rule the planet, and humans would just be rat-sized creatures running around under their feet, as they were for their first 120 million years of mammalian history.